let me continue where I had left off last time, and if you remember I started with small equipment, that is we had a PCB, on top of the PCB there were small devices, and then I have shown you how a small heat sink can be attached to that. And then continuation from a previous course and exercise is saying the small heat sinks and all that, it is not very critical, it is more to improve the margin of safety. So, if you take a small aluminum block and find out its theta, that is thermal resistance, usually thermal resistances for them will be very high, of the order of 20 degrees centigrade, 10 degrees centigrade per watt. But however, since you are dissipating much less than a watt, it really does not matter. Practical heat sinks however come to the range of around 1 or 2 degrees centigrade per watt. But as you go higher and higher, we are expected to keep thermal resistance to the order of 0.0 something, 0.01 and all, or something which is easily achievable by using a large heat sink and making various types of things including forced cooling. So, last round I took you to the next level, show you a few heat sinks, then I showed you a fan, then also I showed you a very now conventional but not commonly used Peltier cooling. In the end of the lecture I will try to show you a practical what I call ice box which uses a Peltier, is not very effective, but still it is used. Then I have taken you to a solar power plant where huge amount of megawatts of power is being generated. Whatever way power is being generated, there will be power loss. So, imagine a 1 megawatt power station, when things are not optimally running, it may have 1 megawatt loss. So, 10% is normal. When 10 megawatt plant has a 1 megawatt loss, a 1 megawatt plant may have a 100 kilowatt loss. Do not get stuck on the figures, the issue being that power loss is real. So, then I showed you large racks which had forced cooling from outside. So, we had those what you call radial fans, and those fans also are a little like a combination of what you will find in a air curtain, plus there actually air is sucked from both the sides and then it is sent off. It is like two radial blowers kept what you call close to each other, but once you stack them or once you put them in series, we need to take a little more care about what air comes in and what air goes out. For that purpose ducting is used, just like you see a ducting in an air conditioning system, it is there. There I have shown you that. Then I have also introduced a little to non-conventional heat pipes. Then I went through in detail through one of the manufacturer's catalog. That catalog which I have shown is typical of everything. I am not endorsing that product, but such things are a good place to start, and most suppliers have become experts in the materials, including the wick structure, including the type of working fluid that they want. So, if you specify the rate at which you want the heat flux to be taken off, saying I have a 10 watts of power being generated and these are the conditions and I need something to be kept, it is possible to make a heat pipe. And there are reversible heat pipes also, but I will not talk about it right now. Then I have also shown you example of a practical biomedical Peltier thing, saying you can keep Peltiers in what you call series or in parallel, and then how you achieve things and all. Intentionally I have avoided giving you numbers, because numbers you need to do directly from the published literature which the manufacturer gives with understanding the literature. Now, let me go forth and show you a few of the things which we have done here. One you see here is a high speed drive. You can see here, thing is written here saying it is not clear here, it is a high speed drive. What you notice, one of the first things you notice is this being a lab setup, it is more of a demonstration prototype. But the critical things what you see is we do have a power supply here. switching power supplies are not yet, when this was made, this is probably around 20 years old, were not that much reliable yet. So, it belongs to the old school. Then the usual things here, you see here this part now is a little to do with the design of it. We have a knob and then you rotate it, and then we can always see what is the setting we have put. So, some of the time they are simple voltage drives, some of the times it is voltage and current. Now, in case if it is AC, we can have a variable frequency drive also. So, you can have devices here which shows which is the speed with which it is running and so on. But this lecture is a little to do with this heat sinks. Now, you see with the heat sink, and added to that, if you see the packaging, the fact that it is on the top and it seems horizontal, it is but practical that it is mounted in a vertical thing. That is, the devices are mounted like this, because it is a lab demo. They have kept this what do you call, so called front panel or control panel at the bottom. So, I have an option of changing all of it to here, so that it can be in the vertical direction, it can be all in the what do you call, in a way you can control. So, the way you do the product design, where would you like to keep items, where you would like to have the control part of it. Every machine has a human or some other control. That control can be remote, including something which recognizes, which makes your attention, or it can be local. So, typically this is typical of it. This being an engineering model, it was there. Now, if sir, you see, this was a solar power pack we had once upon a time done for the one of the government departments. This particular thing is an inverter for a small what do you call telephone setup. The feature of it is you have a very conventional 132 AF heat sink with a small modifications. Then the beauty it is, later on I will show you again once more, because these have all the necessary pictures and all that. This finally shows you the implemented prototype. Can you see here, this is the conventional way. We have the front view, then we have one of the side views, then the other side view. What you notice here is, you see this is the projection of the fins of the heat sink. You see here, and then you see a small slope has been given here to make sure that any what you call air that enters, it enters here and it goes up at all. And other features are, there is a small hinge here. In case you want any repair, you can open these what you call two screws on the top, hinge it out, meaning vertical thing, this vertical thing what you see here hinges out, it comes out this way, and then you can plug it out and continue with your work. So, on one side there is a socket to take out power, and then there is all these protection devices and all that. This is the old style of making drawings, and finally the whole thing is mounted onto a panel with these mounting holes, and these mounting holes and all that follow certain what do you call conventions. I will not call it a standard, certain conventions, so that they can sit on a panel. And this particular thing has been made such that you can work from 100 to maybe around 2 kilowatts, depending on the various type of construction inside. Now, if you look at my pictures here, this one is few of the other things which are in shape. Yeah, this is one, and then afterwards I would like to show you this. This is a unity power factor front end unit. This generally being almost a what do you call something which is a black box to the others. Incidentally, it just happens to be white color, but in general it is a black box. Nobody needs to see it. However, you see that here also we still have a fan which is running there. Most likely inside there is probably a heat sink inside, and then it takes air, probably from here it is ducted, or outside it takes from here and sends it outside. And one thing that is common is, you have seen this mounting plate seen here, and the mounting plate on top now seems to have something like a keyhole. I just like to make these remarks, contrary to what we think, the keyhole should be upside down, is it not? But that is how it is. You put the screw there and then you let it hang. Bottom need or need not be a keyhole. Generally this will be a round hole. So you can put it down and then afterwards you can remove it. So you see here, in this case there is a fan there which is trying to take out heat, and sometimes there may not be even a necessity of a heat sink. We just have to have a fan only as an emergency device. So you have perforations at the bottom, then probably you have perforations at the top and perforations at the back, and it may be mounted slightly away from the wall for the panel, so the cooling can take place. This one is something a little like that. This is a data equation system external module meant for solar applications. Not all of it is gimmicky. If you remember that keyhole again, you see here, this is a keyhole here, this is how it is, and then you see, you may just notice that there is a small gap at the back. You understand, a small gap is there at the back. The heat sink part is turned towards the wall, and on top there is a small hood. This hood ensures that directly water does not come and affect the equipment, in spite of it being typically an IP55 or IP56 type of enclosure meant for external things. The beauty of it is, what to note is, first of all it is sealed, still it has a heat sink at the back which is projecting outside, and you open the door, inside you can find all the electronics which you can service whenever you require it. This is again something which is a little like what you are likely to find inside the equipment. You see here, the power electronic stuff is all hidden inside here, and to simulate how it sits on a panel, a slotted angle rack has been used. This is typical of most power electronic equipment. I do not know, it may be slow start or soft start starter device, maybe for 10 kilowatts. So depending on your various requirements and all that, we have a very neat control of running of a motor, saying the current that it draws has to be used only as a torque and not in heating it up inside or trying to heat up the inertial element of it. The notable feature of it is that in the front you do not find any of the heat generating components or anything, and then plus all the high voltage, because it directly works off the 3-phase 400 volt system we have. This 415 is a nominal voltage under which motors and all are classified. You see here, one more thing I have here, another such device again to be mounted vertically. In the final mounting, probably it will be like this here. So what you see here is, yes, in there it says it is an electronic ballast meant for external high pressure mercury vapor lamps. So what it does is, you feed the necessary power in and all that, and connect it to a large number of lamps, and it does whatever it does. I have no clue what it does except the words ballast and all that, but the thing what we need to notice is that we have this heat sink which is directly mounted on the front of the equipment. So now as we come now, you will notice that equipment can have heat sink in the front, you can have it at the back. Similarly, you can have them on the sides also. The one on the sides I did not get, eventually I will get it and show you. Okay, this probably completes what I wanted to show from our collection of things. Now let me take you on to my funny habit of showing you something from the internet, because we are not in this place of being able to make everything here. You have seen this here, typically it is a full device. I have no clue whether it is a heat sink with water cooling or anything, but you see here whole thing is die cast. So, you have all the necessary advantages of a die cast device. You have seen this, there is a heat sink here which is mounted on top of the equipment in a horizontal position. These are all generally only demonstrative and not the optimum way of doing it, because unlikely anybody will use one equipment like this. But with the available these things and all that, it is sufficient for you, is it not? I would prefer that whole top panel would have been probably made with a thicker gauge aluminum sheet. The whole thing can be made out of a single bit of aluminum, and the cooling is likely to be much better than what you have. You see here, they call it what they call custom anodized heat sinks and all that. I will take you to some other heat sink case. You see here we have a beautiful heat sink case meant for, I do not know what it is, but we have made such equipment earlier. Obviously, I have a power supply here. This could be anything. As I said, I continue to tell you. You see these sides in kept in a horizontal condition, we have these sides which are part of the cooling medium. So, these things are occasionally used as free standalone devices which you can use and go ahead with your things here. You see here, there is a beautiful case here. Now, if you go down here, can you see we have catalogues which show there are computers here without your ubiquitous fan blowing air in and out. So, some extra care has been taken to make cases, okay, so that all these devices which can be used directly in here. Maybe the next picture has a better picture of it. Say one more heat sink with case from the earlier example. This is typical of most industrial equipment. You have some devices here, and then you have all the necessary power electronic stuff which is all hiding behind. See here, neat, is not it? You see at the back, maybe can you see a small openings are at there at the back, and if you still if you see clearly, mounts are there for mounting it, and then you have screws here. Probably if you remove the screws, you can remove the front panel and you have full access of the equipment, similar to what I have shown you earlier. So, these are all typically equipment which are likely to find often. This is probably something, seen that nicely, and then here slowly you will notice something very clear. Heat sinks are not black anymore. Long ago we used to think they are required to be black. Obviously, any aluminum, especially the one which is in convection, the anodic layer has something to do with more with protection and electrical insulation and so on. So, in this case the mounting holes and this whole thing has been integrated into that, and this whole shell goes directly, sits on top of it. Seen here we have cute little various types of variable frequency drives. All of them directly go on panels, and once they are inside a panel, it is possible for you to work with them. You see here at the bottom in the front, you can see the various inputs and things there at the front. You have some inputs and all at the bottom in the front. I will close it here, I will see if the next one now slowly we are getting into other drives. Seen this beautiful top back. heat sinks hidden away. The intention is not to hide them as much as have a safe and secure thing such that we are not affected by those things. So, you have you see here in this particular device we also have fans on top. You see here small, there is a Mitsubishi fan here, and easier for us to AC drive, easier for us to understand what we have. Now, here now I would like to show you something which is a little more quite common, as well as I do not know how to say whether rare or common or anything. Notice here there is a air inlet directly with a filter, which in one of the what do you call earliest things I have shown you. This air filter is a must, otherwise air will get air will carry away all the dust. Any time you have air being sucked inside, also dust gets sucked inside, and so you need to have a filter. The moment you have a filter, clogged filters have to be maintained. So, generally they have a routine. What they do is, this is probably you have to just remove the clips, lift and remove it, and then clean it and put it back inside. This is the reality of it. And then if you see carefully here on the top, can you see here we have outlets for the air here. You have seen this? These outlets will what do you call take away air. The fact that we have a filter here shows that this is probably the inlet. I just wanted to show you typically the construction that is used in the industry. So, we have I think some of you must have heard of Danfoss, which make all these compressors and all for large what do you call industrial equipment. So, typically if you see it is their own drives which have been made. So, the fact that these fins are made at an angle may give you a small hint that you can mount it either in the horizontal or the vertical position. It is unlikely, but still you see here we have one mounting bracket here. I do not know whether this is directly, this may be an attachment on this. Main advantage is air instead of coming out, this part of the thing also is used for cooling the air. So, these are all I will feel it now, I will not call them gimmicks, but what do you call a little bit of trial and error methods to arrive at a reasonably complicated drive. So, the next picture now again it is the same. This is what I have been showing you in our power electronics. This is typically what we make in our own power electronics equipment. So, in general all of them have probably a front panel which you need to have. There are mounting holes can be on top or on the side, and heat sink can be directly closest to the panel, and the sides are all covered. Since these involve only an occasional setting, they do not need that elaborate graphical interface anymore, and these are only sort of safety devices, or during installation you do this. Later on your equipment takes care of the remaining things. We have here it is I am not able to get the picture properly. Yeah. Oh, sorry. Correct. You see here we have things which all sorts of very large equipment. This may be only just a representative picture of how a drive will look. You see here, and then we have an acute something sitting on top of it, lot of power, 500 volt 3 phase DC 230 volts and so on. No? So, you see here these things, are a little generic, but this hat like structure no is the one that gives it the special advantage, and then you have a gap also here. I still do not know fully what it is, but maybe taking a look here will give you a little more thing about it, saying it is for you now to decide what is it that you can do for it. These are the pictures similar to what I have shown you earlier. Now you see at the back of the drive, and then you see the nice 3 connections here. Probably these represent the UV, W or RYB connections, and probably somewhere there is a what do you call some this 500 volt I mean sorry 400 volt bus, and this sits on it, and then you see here we have this very nice mounting holes. After you insert and push them down, they have given a U type thing here. So, when you want to unscrew it, you just probably need to loosen these 2 things and loosen 2 screws here, lift it and take it off, and our equipment now has to fit all this. Now you know what is there on top. Can you see what it is? What they have put is, they have put a huge fan there. Because this is a little probably lower rated, you have a single fan, the other one no, the bigger one probably has 2 fans there on top, and this lets out the actual thing here. Can you see here what we have at the bottom? We have the same heat sink, and we have all the what you call power devices, and you see here probably these are all IGBTs or something which is mounted here. Then you have gating circuits, then we have all the other cutting connection diagrams, and the mounting arrangement what I spoke to you here is at the bottom here. So, this is typical characteristic of any of the power electronics equipment, and these can now directly go into a panel. You can do whatever you want with it. See here slowly you are able to make out probably line 1, line 2, line 3 is probably what they call. I have no idea about their designation, but here these beautiful stacked PCB connectors. You have 1 level, 2 level and 3 level, which are typically that Phoenix has multi-level connectors. So, finally equipment probably looks like this. What you saw inside, no, this once you cover it up, it all comes here, and this is what I was showing you earlier. See here all of them are typically generic, except that it says, I mean very threatening thing saying it can be obsolete. So, I will now close this, and I hope you have read along something with me and gained a little bit of expertise on this. So, for today I will just take a small break. I just wanted to show one of the boxes I have here. I will bring it along. If you remember earlier I was speaking a little about this to you. This is typically the practical use of a Peltier module. You see here we have something going out, then we have inlet and outlet, and depending on which way you plug this in, no, minus and plus, it is possible for us to either cool it or warm it. And when you open it inside, all you will find is space. Can you see? The effectiveness of this whole thing is giving it a good insulation. And if you see at the top, we have 4 screws here. There was a metallic thing which will keep things cool. So, you need to heat or cool your lunch or your what you call beverage. After cooling it, you keep it here, it maintains around 5 degrees centigrade. So, these were quite popular at one time. Even now they are sold, but they are not very effective. And then after I stopped playing with it, it started smelling, and we had to discard it. And another beauty is, you see this connector, this connector can be plugged in both ways, saying you can plug in like this or you can plug in like this, both ways. It is not, there is no barrier which says only this is the positive and negative. If you connect it in the reverse, it does not matter. If you connect plus to plus, it cools. If you connect minus to plus the other way, it warms up. Some reason now in either conditions, it is giving smell and smoke. So that means we have learnt our lesson in it. A warmer box, you do not need to have all that control, and Peltier is not very practical in a heating application. However, if you want to do both heating and cooling, there you want. In this case, just to demonstrate, I had started with one of these things. This one is a small 5 watts heating element taken from a mosquito heater, and the whole thing has been clamped with all the necessary things. And then I have since this is a 230 volt device, I have connected this here directly. Okay. And the whole thing sits neatly in this, in this way upside down. Instead, for practical purposes, we had made something like this. Now, this one heats much better than a Peltier junction. So, maybe I can just show you, lift it a little high and see, you see here, this heats much better than a Peltier junction, though it is 5 watts. If you properly insulate it in this space, after around 30 minutes, the temperature rises all the way up to 50 to 60 degrees centigrade inside. Where do you use it? In some applications, when you need to, this thing, typically if you want to keep your lunch warm, you can use it. And in this case, it works with 230 volts, and it is also possible very much to replace all this with a simple resistor. This one has a thermistor, 2 slope thermistor from a heating coil, mosquito heating coil. If you replace it with a 12 volt device, you can make your own heater without having to go to the Peltier junction. This is what you will find in, if you take your lunch boxes, several of the lunch boxes have it. So, allow me to one more time search on the internet for a typical device. Okay. See, we have this beautiful device here. This is, they call it a heated lunch box. Contrary to popular mythology, they do not work with a Peltier. Peltier is a waste of waste of effort. The amount of control and all is not required. All it has is usually a small heater. Typically, I will see if he has written anything. Yeah, he says it is a 40 watt heater. So, actually it is a 40 watt with a little bit of control, probably a diode control. After it reaches certain temperature, a thermostat switches it off and switches it on, or gets it into the low power mode. So, typically something like this is enough, but the beauty of it is about the insulation and about the rate of heating and total mass that is included in it. But if you have to cool something, then you end up with the cooler devices, typically Peltier. And if something can be brought near ambient, then to a heat pipe. Okay. Now, we come to other thing, can we have secondary and other conditions? Now, saying inside you can have a heat pipe and outside can we have a Peltier and then try to cool? Yes, all possible combinations exist in real life. So, thank you until we meet again. Okay. My suggestion is, meanwhile, you also go on this thing and scrounge around or search around for these devices. These are all easily available, and 3 small things you can do is, you can try to make your own Peltier small thing, cooler device. So, there are Peltier devices which can keep a small volume cool. I had shown you last time, if you remember, one teacup warmer. So, if you put a Peltier, maybe you can make a cooler also in the same thing. And in my case, I would rather keep the warmer thing down, keep the Peltier, and then when we do not want it, the Peltier can be on top as a cup which has other thing, you remove that and keep a this thing and insulate it. In that case, if you are to take, let us say, any cool juice or soda or anything, you can maintain it at a drinkable temperature around 10 or 15 degrees centigrade. At that temperature, not much of power is involved, and we can make it easily. So, I suggest you try the experiment. There are enough data available on the internet. I suggest you try it, and then in case you feel like it, post it somewhere so that I can see it on the blog. Similarly, heat pipe is something which is a little difficult to make, and with unpredictable results. If you can lay on your hands on a heat pipe by contacting the manufacturers, you can try also. For all other things, the only thing we have is fans, heat sinks, and our own creativity on how do you mount the heat sinks, sides, front of the equipment, rear of the equipment, sometimes on the top. Then you have to create a duct like thing, and if it is panel mounted, you have something, or if it is a table mounted, you have something else. So, thank you until we meet in the next session, including what is a vapor chamber and where are you likely to see them and so on, which I have given a hint earlier. And if you have patience and if you go to Remsburg's that thing, I will just show you there is an interesting thing which allow me to So, if you go to this Remsburg, the later chapters, there is a lot of stuff about pool boiling and how things take place. There is a lot of stuff about what you call phase change cooling. In the case of phase change, continuously there is boiling, and there will be condensation in other place. This is the probably starting point of any other phase change type of cooling, including you can have boiling, that vapor chamber and so on. All of them depend on it. So, I suggest you download this thing or any other equivalent book, and I have shown you about graphs here and so on, saying where these things where these things work, and where is we have a liquid and where do we have a what you call condensation, vapor and all this. You read it, and I will end the lecture on this note. So, thank you until I will get back with more topics, and maybe a practical demonstration of one liquid cooled system which we had made. I hope the video is there with us. So, thank you. That will be all for today.